Hello and welcome. In this part of the video lecture, as a part of the course Programming for Problem Solving Lab, I'm STG by Santhya, and today we will be seeing about Lab Task 6A. So what is Lab Task 6A? Lab Task 6A is, sixth lab task contains the programs on arrays in which we are trying to talk about sum and average of elements of an array, followed by linear search and binary search. So today we will look at 6B, that is linear search. Let's directly start with the implementation of linear search. So first of all, before going ahead to look at how to execute linear search, let us once take a minute's time and discuss what is linear search. So linear search is a searching technique, also known as sequential search, in which the elements of an array are, searched one after the another, starting from the first element till the last element. So something like this, isn't it? So before that, let's take up, this is a program in which we are trying to implement linear search. So what is linear search? This is a linear search code. I have an array A of 20 elements, and I'm searching for an element called key. So first of all, I read the elements of an array. How do you read the elements of an array? Using a for loop. For I equal to 0, I less than n, I plus plus, scan of %id ampersand A of I. Then you also read for the element that you want to search, which is nothing but the key. Here I'm taking it in a variable called key. So how does linear search work? Linear search is a process of searching all the elements of the array from starting to last. So set your I to 0 and as I less than n, I plus plus. If any A of I is equal to key, that means if the element that I want to search key is equal to A of I, then we say that %d, nothing but the key, is found in the list at A of %d. %d is the position that the element is found. So therefore, before that, we can also print successful search /n %d is found at A of %d. Return is used, break is used, exit is used, a lot are used. I just used return here. Return gets the control back. So therefore, now what happens? Imagine you don't get enter into this inner if condition implies that you did not have any A of I which is equal to key. When I don't have any A of I which is equal to key implies that clearly that my search is unsuccessful. So therefore, you say that the search is unsuccessful /n. You say that the search is unsuccessful. The search is unsuccessful and %d is not found in the list, and just we stop. Okay, because we made some changes, let's save the code, compile the program to ensure that there are no bugs, and run the program. Okay, so enter the number of elements. I wanted to enter some 5 elements. Let me give the list 34, 67, 8, 9, and 12. 1, 2, 3, 4, 5. Yes, we have given 5 elements. Enter an element to search for. Suppose I'm searching for 89. Enter. What does it say? It clearly says that search is unsuccessful and 89 is not found in the list. Okay, so let's run again. Let's run again for some successful elements. Okay, enter some elements. I gave some 7 elements. 1, 2, 5, 8, 3, 9. So how many elements? 1, 2, 3, 4, 5, 6, and the last element 0. Okay, enter an element to search. Okay, let me give 8. Okay, what did we get? The search is successful and 8 is found in the list at A of 3. So let's just check, is it A of 3? 0, 1, 2, 3. Yes, exactly, it's A of 3. So isn't it? This is how we get our output, and this is how you test your program. Now, imagine if I want to use a function and write it separately. What is a function? A function is a block of code that does a specific work. So if I want to just, make that change, I want to probably put it as, PL T, this is 6b, so therefore let me put it as 6b.c. Okay, let's write a function for this. Linear search, this is PPS lab task 6b. Okay, here we are trying to implement linear search. This part of the code needs to be kept in a function. So therefore, what do we write? Here, we just call a function called linear search. Okay, that just returns a value X. Okay, that just returns a value, or else you can take simply position. That just returns position. If I call a function linear search, that returns a position, whereas I'm giving the array A, N, and the element key that you want to search. N is the size of the array, A is the array that you want to search, and key is the element that you're searching for. So, and then write down your logic. This is the logic that we'll write. Okay, so we either print successful search or unsuccessful search, and then we'll return the value. Okay, so this is what we're going to check out. So yes, close, then you printf. Okay, there's a lot to do here. If your position is -1, then what is that you got to understand. Now that when you know our position is -1, we know that the element is not found. So therefore, this instruction, this instruction got to come here. So therefore, this part of the instruction, I'm just cutting and I'll paste here. Yes, when you know that your position is -1, you can say that your search is unsuccessful and the element is not found, the element is key. Else you know that your search is successful. So because you know that your search is successful, you can just, cut it and just paste it here. Alt E, paste. Okay. And you just close the main function by just writing get ch and close. Did I write int main? If you have written int main, we also know that we got to write return 0. So this is the function, but there is one thing called as position that we need to write. This is position. Okay. So this is what happens. I'm calling a function called linear search. So in the declaration section, write down the function for linear search. It returns an integer that is the position of the element. So in linear search of how many is it input? It's taking an array A. So array A, comma, whose size is n, and it is searching for an element called key. It takes an array A of an element size and searches for an element called key. So it's time for us to define the function in the subprogram section. So let me write int linear search of, let's name our variables here, int A, comma, int n, comma, int key. So this is what a function is working with, right? So therefore, this is how you write. This is the place where I'm also showing you how to implement. Okay. So yes, you have an integer I here. So therefore, integer I for I equal to 0, I less than an I plus plus. If you found any a of I that is equal to key, we will simply return the index indicating that it is successful. On the other hand, if you do not get anything as such, then instead you will return what? What do we return? Instead, we will return -1, indicating that the search is unsuccessful. Indicating that the search is unsuccessful. So let's just save the code. Compile your program. Okay, there are some errors. Undefined symbol ELS. Okay, sorry, else E is gone. Okay, fine. Alt F save. Alt C compile. Alt R run. Number of elements 5 elements. Enter 5 elements 3, 6, 1, 2, 7. Okay, I'm searching for the element 6. Successful search 6 is found in the list at A of 5. Okay, there's a mistake here. Okay, yes, we didn't update, right? We wrote I, but I makes no sense. I value is 5. So, but we got to not write I, we got to write position. Yes, Alt F, save, Alt C, compile. Every time you make a change in your source code, you got to make it. So let us do it for 3 elements, 1, 5, and 3. Okay, I'm searching for 5. It says the element 5 is found at A of 1. Okay, let's run again to check if there is anything unsuccessful. I'm again doing for 3 elements. 5, 2, and 1. Okay, I'm searching for 9. 9 is not found in the list. Students, hope you got what is needed in this concept. Okay, so I recommend you to write the code on your own and try to execute and see how does linear search work. Good day.